In this video, we'll review some of the basics of the JavaScript programming language, as well as some of the new features introduced with ECMAScript 6. We'll talk about some techniques that you can use to load JavaScript files efficiently. We'll talk about the new const and let keywords. We'll talk about the different data types that are available in JavaScript. We'll talk about some branching using if, else, else if, and ternaries. We'll talk about how to implement loops with for, with the for construct, for of, and the for in. Both for of and for in are new loop constructs that were introduced with ECMAScript 6. And then finally, we'll talk about truthy and falsy and how we can use that to improve our branching and make our logic a little bit cleaner. Okay, so let's talk about scripts first. So to add JavaScript to your pages, you really have two options. You can either put it into an external script file, or you can embed it in the document itself. If you're going to put it externally, generally we're going to put it in a folder named JS, short for JavaScript. Generally, that's where we're going to put functionality and logic that's common to all of our entire website. So if multiple pages need to use that function or that logic, then you definitely want to put in an external script. The way you link them up is going to be with the script tag. And do be forewarned that remember that the order of your scripts matters because that's the order that they're going to execute in. So for instance, if you remember right, there's some dependencies between jQuery and Bootstrap. So in your script, so you'll need to make sure that those scripts are all in the right order. So for example, if I have an external script file that I've placed in the JS folder, and then I've named the file main.js, I would have a script tag something like this in either the head or the body of my document. If I want to embed JavaScript directly into the page, and I might want to do this if I've got logic that's only used for that page and not used on any other pages, then I may want to embed it into the document itself, and I also will use a script tag to do that as well. Now, note, if I've got an external file, I'm going to set the source property and give it a path, but I'm going to leave the body of the tag empty. Whereas if I have it embedded into the HTML itself, I won't have a source attribute, but I'll put the JavaScript in the body of that tag. So here you can see I've told it to show an alert window saying hello world when this script runs. Okay. Now, one thing you might want to pay attention to, or there's a few different ways to do. If you're adding JavaScript to your page, you can really either add it to the head or you can add it to the body. When you add it to the head, there's certain pros and cons with that. If you add it to the body, there's different pros and cons there. Now, typically, if you are going to add it to the body, the one place you want it, the only place it really makes sense, where you really get any advantage, is if you add it after all of the content. So you add it right before the closing body tag, is where you're going to put it if you're going to put it in the body. So let's say we put it in the head. Okay, if we put it in the head, then the script has to be both downloaded and executed before the page actually loads. So it's going to actually block the rendering of the page until the script has been fully downloaded and executed, which means that as long as that's happening, the user is going to see a white screen. Now, this has some benefits when you're using that script to track page views, because it means you won't miss a page view because it happens before they actually see the page. So it has some benefits there, but in general, it's really going to slow down your page load times to put it in the head, because downloading, parsing, executing the script, all of these things have to happen before any content is shown to the user. So if your script is relatively large or there's a lot of logic in there, the user may be staring at a white screen for a few seconds before they actually see any of your website's content. So, and that being said, most scripts also depend on modifying or working with the DOM of the page. And if you link the script up in the head, well, all it's really going to be able to do is say, okay, run my logic when the page loads. So it blocks the page from loading, but then it's not able to do any useful work before the page actually finishes loading. So most of the time, you're just losing out if you're putting your script in the head. On the flip side, if you put the script at the end of the body, in general, it's going to speed up the load time of the page, because the script won't even start executing until the page is actually fully loaded, since it's at the end of the body. That means because it has to read it from the top to bottom. By the time it gets to your script, the DOM will basically be done. And it has a big benefit that the user isn't seeing a blank white page while the script is downloading or loading or executing, because by the time it actually gets to be executed, it'll be finished. Okay. Cons, as far as putting it at the end of the body, it does mean that the script doesn't actually start downloading until the browser sees it, because the browser doesn't download files until it sees them in the HTML, sees a reference to them, or the CSS, wherever. It doesn't download them until it knows about them, which means it's going to have to basically load all of the content and then download the script. So it could still result in, if you've got a lot of content on that page, it still could end up being quite a while before that page is actually interactive, where your script actually starts running again, if there's a lot of content on the page. But in most cases, putting the script tag at the end of the body, just given between these two options, usually the right answer is put it at the end of the body, is you'll get a better experience for your user than putting it in the head. Now, there are some additional options which are available now in modern browsers. So it's not simply a case of, do I put it in the head or do I put it in the body anymore? There's actually several more options for how I can bring in those scripts. Okay, so first and foremost, the one you're familiar with, right, is we just create a script tag. All of these examples referring to an external script file. Because some of these tricks don't work. Most of these tricks don't work with an embedded script file. With this, the script is, the script has to be downloaded, parsed, and executed whenever you run into the script tag. Whenever the browser sees the script tag, it's going to block rendering. It's going to stop doing any work until it's finished that script, and then it's going to go back to work. This in general will give you the slowest load page times if you're just taking this naive approach, which is why we want to look at some of these other options that are available, which will speed up the page load times. So that's kind of your vanilla option you're probably familiar with, but we're going to talk about 3 other options today. So the next option that was introduced most recently is this async Boolean attribute that you can add to your script. What that does is it says when it encounters, so it went in with this, when it encounters the script tag, it'll start downloading it. It'll start downloading the script file, but it's not going to block rendering while it's downloading. Okay. And then the script is going to execute as soon as it's downloaded. So it says, okay, I see your script tag, keep rendering the page. And then once it finishes download, it'll kind of interrupt the render and go ahead and run the script then. In general, this does give you faster load times, but the problem is that with async, short for asynchronous, the order the scripts execute isn't guaranteed anymore. So for instance, if you have jQuery and then Bootstrap and then your own script, which need to execute in that order because they depend on each other, async doesn't work because they will just be run in whatever order they download, which often means that your script's going to run and then maybe jQuery and then Bootstrap or somewhere misarranged like that. More than likely, it's not going to end up working because the scripts are out of order. So this is generally unsafe for most scripts. Adding the async keyword is generally unsafe for most of the scripts that you write because most scripts depend on the ordering of them. It does work well for things like tracking traffic, displaying ads. We talked about watching for page views. This is a good thing for that because those generally don't interact with any of your other scripts. Generally, working, tracking traffic, tracking page views, and working with ads, generally none of your other scripts are going to touch that, so it doesn't matter when they run. So oftentimes for things like that, you can go ahead and put them in the head, so they'll download as soon as they're seen, but mark them as async. Now, a more common case that works in more cases than async is to add the defer keyword. Okay, the defer keyword is very similar to the async keyword with some minor differences. So with the defer keyword, the script is still downloaded when it's seen, and you can see with any of these three examples, the script starts downloading when we see the script tag. It always starts downloading when we see the script tag. Which one of the things that means is we can we can move it into the head to make it download it sooner or start downloading it sooner. The upside with the defer, similar to how async works, is that it doesn't block the rendering while the script is being downloaded. However, with defer, rather than just running the script whenever it gets downloaded, defer actually waits until the page is fully loaded or fully ready and then runs your script. So what that means is you can even put the script tag in the head and it'll go ahead and start downloading it as soon as it sees it, but it won't actually run your script until the page is loaded. So for a lot of scripts, generally for a lot of scripts, this works really well. You can easily just, okay, I'll keep it in the head, but it'll run it as if it was the end of the body in general. Now, one gotcha with this is you can't use this with embedded scripts. Same thing's actually true with async. Neither of these can be used with embedded scripts. Embedded scripts are always run at the time they're seen. So that can cause an issue with timing because it means that your embedded scripts will actually run before all of your scripts that are deferred. So you can't really intermingle embedded scripts and deferred scripts. So if you do use this, it doesn't mean that all your scripts have to be moved to external files, even if they're only used on one page. But in general, this option is safe. In general, this option can be safely used with nearly any script out there. I would still recommend for tracking traffic to use the async keyword, but you can use this for most cases. And in general, this will speed up the load time for your pages. So you've got this is generally the slowest, and then this is kind of faster than that. Async is usually the fastest, but in general, this is usually the one you end up picking because that's the one that works for your case. The thing I was going to say, because it waits because defer makes it wait until the page is loaded, this generally means that it will actually run the script until the DOM's there, which means that it actually runs at exactly the time you want it to because, well, now I can refer to all the bits on the page. I don't have to necessarily wait. Now, I would still use the jQuery ready and wait till the page is, the DOM's fully loaded according to that. But it means that it's going to happen closer to when that DOM event actually fires. Next up, and this is kind of an interesting option, you can add an additional tag to cause the script to load earlier. So this is another way that you can do things. This does actually work in all cases, but the only downside between this and defer is generally that it's a lot more code to write than just adding the defer keyword. But you can basically get the same benefits using the preload construct. So the way this works is you're going to add link preload. You'll always add this to the head. And then you can add your JavaScript wherever you want. The JavaScript can either be in the head or it can be in at the end of the body. You can have the defer keyword or cannot have the defer keyword. The preload says go ahead and start, as soon as you see this, go ahead and start downloading this file. Don't block the render or anything like that. Just go ahead and start downloading this file because I'm going to use it later. So here I'm telling it to preload it as a script file. I'm telling it to use cross-origin anonymous, which says don't send any sort of login credentials when you ask for this file. Don't send any cookies or things like that. I'm telling it the path to the file. So here I've got JS, main.js, and you can see that's the same path that I have with the other ones. So I'm going to add this link before I add my script. Again, my script can be either head and body. I can't just add this. Now, another thing to know with this preload actually is usable for a lot more things, and that's part of why it says as script. Because you can also use this preload to start downloading images and CSS files and video files and whatever font files, whatever other files that your page may need. You can go ahead and tell the browser to go ahead and start downloading it so that it's ready for when I need it. Because otherwise, your browser won't know to download it until it gets there. So this preload construct is actually well worth reading into because there's a lot of things that you can do to give the browser some information about resources you're going to use later, which can really, really load up your page times, your page load times. And this is really, really highly recommended if you're downloading any scripts or CSS files, any sort of file that you might be downloading from a CDN. Make sure you use this because it will speed it up. This gives you page load times that are between defer and preload. Assuming that you put your script at the end of the body or mark it defer, these can give you equivalent loading times. Okay, so those are your options for adjusting how your JavaScript is run and executed. Again, most of the time I would recommend going with the defer route, but there are also definitely times where this is a good choice as well. But using the regular script tag, the naked script tag as you will, is usually your slowest option, and async is usually an unsafe option for most scripts. So those two are the ones that we're going to pick most of the time. Okay, so now let's talk about variables. Now, variables, I'm sure you're familiar with them, and every program you write will have variables. But with EasyScript 6, which is kind of the latest version of JavaScript, I think it came out in these things were introduced in, say, 2016 or so. So there are they have been around for a few years. I want to make sure you know about them because you may know about a few things here because you may have not learned them in first semester. So let's go through some of the things that are new. Okay, so nowadays there are actually 3 different ways to declare variables in JavaScript. You can declare them with the var keyword, the let keyword, or the const keyword. For example, here you kind of look at the context. If I say var x equals 1, so I'm declaring a variable named x and assigning it a value 1. I'm declaring a value y, assigning a value 2, declaring a variable z, and assigning it a value of 3. Now notice that I said z is a variable. A lot of people get that confused. Z is technically a variable even though I'm used that const keyword. That doesn't mean it's a constant in the sense that you're used to. It means it's a variable that can't change after it's been assigned. We'll go through that. But you can declare your variables any of these 3 ways, and there's upsides and downsides to why you might use one over the other. So I want to make sure you have a really good grasp of what those do and when you might use them. So let's go through a comparison of the different keywords and what they mean. So first of all, var, which is the one that's been with us in JavaScript for forever, is the basic way, hey, I want to say, here's a variable named x. The problem is, with its history, it's been around the longest, there's a lot of bugs and weird behavior in there to support old code. So first of all, when we're talking about variables that are declared with the var keyword, they are what we say function scoped. So they're scoped not to where you declare them. So if I, for instance, declare them inside a while loop or a for loop or an if else, I would expect that it's scoped within that block. And that's the way it is for most languages. Well, the way that JavaScript works, if you declare a variable with var, it's actually hoisted out to be at the root level of the function. You kind of think of, if you declare it with var, it's the same as declaring it at the top of the function, right? And that's usually not what you want, and will usually get you into all sorts of weird bugs. So that's generally can be a problem. Also, a weird thing with var is that if I say var x is 1, I can again say var x is 2, and the browser won't give me any sort of syntax error because I can redeclare the variable and it won't give me an error. That's not generally good. Another thing with var is anytime you declare a variable with var, specifically in the global scope, it's going to get added to the global window object. So remember, the window object has a lot of useful things on it and is available anywhere in our code. If I say var x is 1, there's now a property x on that global window object. And that can be a problem if I override something really important, like window.location. If I say var location is 3, I have now changed window.location to 3, and that can lead to a lot of unexpected behavior. Next up, kind of comparing them. Var is obviously not const. I can assign other values to it. I can change it from okay, I declared it as x is 1, and I can immediately, the next line, change it to 3 or add 5 or do whatever I want to change that variable. In general, well, let's go look at some of the others. So coming back to, let's look at let. So let is very, very similar to var. Difference being is it's now block scoped. So it's scoped to the block that you declare it in. It's not available outside of that scope. Same way that you're familiar to working with Java, working with variables in C# and most other high-level languages. So it's scoped to the block. Any variables that you declare with let are not added to the window object. you have to intentionally say window.y is equal to this. It won't automatically add anything to the window object, which is good. It's not constant. I can change it. And then last up is const. So const and let, very similar. They're both block scoped, which is great. Neither of these are added to the window object. Good. However, const can only ever be assigned once. So once I give that const variable a value, I can't give it another value. Okay. You can give it a value, but then I can't change the value. So I can say const z is equal to 3, but if my very next line of code was z is equal to 4, I would get an error on that line. Okay, so that prevents you from changing it. Now, I would say that doesn't mean that consts are constants, right? I would not call this z a constant because it's still valid syntax for me to say, well, const z is equal to x plus y. If I said x plus y, well, I'm pulling from other variable values to determine the value of z. So the way to think about const in JavaScript is const is maybe not the right word to have in your head. I would think read-only or final might be a better word to have in your head, and we'll talk about how that refers to in some other language. So in general, as far as usage goes, don't use the var keyword to declare any of your variables. There's no reason to. It's always a bad choice. Const is generally the option you want to choose. You want most of your variables to be const, as many as possible. That will get you to the best possible code, is to declare nearly all or all of your variables as const. There are cases, obviously, where you do need to change the variable, where you do need to reassign it, in which case let would be your second choice. You know, if const doesn't work, if const isn't an option, if you can't rejigger your code to be const, then use let. But you should try to use const whenever you can, even if that means changing your code. So there's some articles that I've posted on to Perusal that you'll want to read about all the differences between these, because there's a lot to that. Now, next up, we can declare variables as const. We can actually also declare functions as const. And that's generally a good thing, because I don't want to say, most programs, you don't want to say, okay, this function is, I'm going to declare it this way, and then a few lines later, I'm going to declare it with the same name, but a different body, right? A different implementation. So generally, we're going to declare our const. Generally, you want to declare your functions one of these two ways. So you can either declare a function like this, function, parentheses it takes, and there's the body. So in this case, this foo1 is going to be a function that just logs foo_bar to the console. Or I can declare it this way using the arrow syntax. And these are, in this case, equivalent. We'll talk more about the arrow syntax later in the next lecture. So foo2 writes foo_bar. But you'll notice that the reason the place where the const comes in, const, the name of the function equals, here's the function. Okay, so let's talk about, you may have seen the const keyword or seen it in some other languages, and it's got kind of a long history. So the const keyword originally was introduced into the going back in the C family. C and C++ both have the const keyword, but in their sense, there are some differences. So the const keyword in JavaScript says that once you assign the variable value, you can't reassign it. One gotcha with JavaScript is that if you assign it a object or an array, that object array is still mutable. So even if I say here const array, const array, give it an array, I can still go in there in the very next line and say, let's change array index 3 to 52. That's still allowed to modify the array afterward. Same thing with modifying objects. So that's what const means. And Java is the same way. They just use the word final to mean that same thing. So Java's got the keyword final behaves the same way as const does in JavaScript. C# actually has two keywords when you're referring to constants. There's the read-only keyword and there's the const keyword. The way that the JavaScript const keyword works is actually equivalent to the read-only keyword. In C#, that const keyword with that const keyword, your any values you put in there have to be two things. They have to be primitives. So like numbers and strings are kind of the ones that you can put in there. I think enum values fit in there too sometimes. Or no, yeah, enum values do. But in general, the rule with const is that they have to be compile time consts. So I can't in C# say that an array or an object is const because it would be mutable. So on the other hand, read-only has the same meaning as const does in JavaScript, where it says that once you assign a value to it, you can't reassign it, but you can put objects arrays in there, and they're still modifiable. In C and C++, that's where these keywords where the const keyword was originally introduced. But in that context, not only did it mean that you couldn't reassign a value to the variable, it meant that if it referred to an object or an array, that also had to be immutable. So that existed in the world of C and C++. But what happened with that in saying, well, okay, these objects have to be immutable, it actually created a lot of headaches for developers. You might think, okay, well, I should make that immutable, but as it turns out, and what we found out with C++ and C, is that created many more headaches than it was worth, which is why most modern languages, when they have a const keyword or such, they don't have that requirement for immutability that used to exist in C and C++, because it created a lot of headaches and a lot of problems. Okay. So next up, we'll talk about data types. So we talked about how to declare your variables. And I definitely recommend reading the articles to find out more about some of the differences between const and let and the details of how you can use that. We'll talk more about those as the semester goes on. But let's talk about data types. So what data types are available in JavaScript? So there's a few basic data types available. First of all, there's a string. String's the same as it is in C#. It's just a series of characters. But with JavaScript, you can declare your strings either using single quotes or with double quotes. I'd recommend you declare most of your strings with single quotes because it makes it easier once you try to put HTML into your strings. So you can do it with either. There's not a special whereas with C#, the rule was single quotes were a character and double quotes were a string. With JavaScript, they're both strings. You can also have numbers in JavaScript, but the only number type that exists is a double, right? So if something is a number, the C# equivalent of that would be a double. There's really no integers in the world of JavaScript. Okay. In the same way that there are in C#. So if I want to declare numbers, I could say maybe the age is 30, rate is 3.5, m is 0.7, or I could say the speed of light, well, which is c, is 3e8. Well, this is an interesting sort of notation because it's shorthand for scientific notation. So that's 3 times 10 to the 8th. So you can declare numbers all of those ways, but notice that even if I declare it as an integer like this, even if I say that it's 30, it's actually still going to be a floating point number. Okay, so that's a very important thing to understand and remember as you're working with numbers in JavaScript, that they're always floating point. They're never integer. Next up, we've got the Boolean type, and that can be true or false, as you're familiar with. I can have arrays, and so those arrays are generally, when I declare them, when I'm talking about that, I'm going to start them with a square bracket and end them with another square bracket. So here I've got an array that has the elements 1, 2, and 3. Arrays in JavaScript can have anything in them. They're not restricted to, they all the values in an array have to be the same type. So I can have arrays in JavaScript that have numbers and strings and objects and other arrays inside of them, and JavaScript doesn't care. You can have any mix of data types in an array. And if you're looking for the equivalent over in the C# world, the C# equivalent of arrays in JavaScript are actually dictionaries with the key of an int and values of dynamic. That's actually the closest thing you can get to. That's the closest to how JavaScript arrays work. Next up is objects. So we can have objects in JavaScript, and we can just create them as we need them. We don't necessarily have to create a class we don't have to declare a class in order to have an object in JavaScript. So here, if I want to just create a literal object, this object's going to have two properties, first and last. So first is set to the value of John, last is set to the value of Doe. So now I have an object with a first and last name. So I can very quickly create objects that way, and they can be fairly free form. Again, this is kind of behind the scenes. This is implemented as a dictionary from strings to, well, any type. So your properties can have any value. And then finally, another data type that often occurs with JavaScript is the undefined data type. Now, this one gets kind of interesting because there's not an equivalent data type in C#. You don't have undefined. If a variable has an undefined value, you're going to get a compiler error saying that, hey, you haven't given this variable a value. So in undefined in JavaScript means what I just said, means that the variable has not been given a value. Okay, it's not been assigned. So for instance, if I have a variable like this, I've declared it let x. I have not assigned it a value, so it will have the value of undefined. Similarly, if I can actually just assign y the value undefined, that would be another way for it to get the value undefined. Let's say, for instance, or another way to get it undefined might be if I have an array called R, and I refer to index 20. Let's say there is no index 20. Well, that would be normally in C# I would get an array out of bounds exception for that. In JavaScript instead, you get an undefined value. You get an undefined because it's like, well, I don't know what's at that index. There's nothing at that index. So you're going to get back undefined if you refer to array indexes that don't exist. Similarly, if you're working with objects, let's say person is an object, I want to go to the age property. Well, if the age property doesn't exist, then I'm going to get undefined. So I can get undefined because I haven't assigned the variable a value. I can get undefined simply because I assigned it undefined. I can get it because I'm referring to an array index that doesn't exist. Now this assumes that the array exists, but there's not an index 20, because if the array doesn't exist, then I will get an exception when I try to go into the next 20. Or I can get it with an object that doesn't have that property. And similarly with an object, if person is null, person doesn't exist, then trying to get to age will give me an exception. So this only works as long as both array and person are not null. Okay. So when we're working with numbers in JavaScript, and remember that numbers in JavaScript are always floating point numbers, there are some special numbers in JavaScript. So the first one of those is going to be the NaN, known as not a number, which gets kind of weird because not a number is actually a number. It actually is a number type, and it can be stored as a number, quote unquote. But it represents that number, that quantity that you want there, cannot be calculated. And there's a few different ways to get that, and we'll talk about that in a minute. But not a number represents that this thing cannot be assigned a numerical value, okay? Or that the result of your calculation, there's no good answer for it. Next up is infinity. You can get a positive infinity, but this doesn't represent maybe infinity as you're used to in the mathematical world. Infinity just means that the number was too big to store, that I got a number bigger than could be stored in a double. So this is still generally a valid number, but it's just too big to be represented. Negative infinity is the other side. It's a negative number that is too big to be represented. Then finally, other special values that you might get out of calculations are 0 and -0, which seems kind of odd because from a mathematical standpoint, there isn't really such a thing as a positive 0 and a -0. But you have to understand when you're looking at 0 in floating point numbers, and all of these cases that we're talking about here are not specific to JavaScript. So any language that follows the IEEE 754 standard, which is basically all the languages, if you're working with floating point numbers, you're going to run into this. 0 actually, it might represent 0, but in general, the proper way to think about 0 is it represents a positive 0 represents a positive number that's too small to be represented, that it's below our precision. Similarly, -0 represents a negative number that is too small to be represented. So both of these don't necessarily, 0 and -0, don't necessarily represent 0. They just represent a number that's maybe close to 0 or too small to be represented, too small to be stored. Okay. So how can we get some of these values? Because we can get all of these values starting from normal good numbers. So for instance, if I have this expression, if I say parse float, I try to parse ABC. Well, ABC is not a valid number. Parse float will actually return NaN, not a number. So if I continue doing math with that NaN, I will have NaN at the end. Next up, if I say take 1 divided by 0, remember 0 represents a really small number, so take 1 divided by a really small number, I'm going to get infinity. Versus if I take -1 on the top, so I've got negative divided by a really small positive number, I get negative infinity. Or similarly, if I have positive, negative infinity, -0 at the bottom, I'm going to get negative infinity. So you can divide by 0 in JavaScript, and generally with floating point numbers, and not get an exception. What you get instead is positive or negative infinity, because remember that 0 represents a really small number, not actually 0. So you can get infinities out of doing calculations that don't necessarily that seem like they maybe shouldn't, as long as your numbers are small enough. Also, if I say 0 divided by 100, well, 0 divided by anything in general is going to be 0. So 0 divided by 100, 0 divided by infinity is 0. But the weird one is some of these here. So if I take infinity divided by 0, remember infinity is a really large number, 0 is a really small number, I'm going to get infinity. However, if I say infinity divided by infinity, well, we have two really large numbers. We don't know how big they actually are. At this point, we've forgotten what numbers actually were there. So infinity divided by infinity is actually not a number. Similarly, if we take 0 divided by 0, well, these are both numbers that are too small to be represented, so we're going to get nan. So you can actually get nan from dividing from really large numbers, or you can even get it from really small numbers. That's not the only way to get nan, is not this way. That's not the only way to get nan as parsing float. You can get these values a lot of different ways. Okay. Other special values that you might run into. So we've talked at least about one of these here. We do have the concept of null in JavaScript, and that represents the absence of an object or the absence of an array. That means that the value actually of the thing is that there isn't a thing there, is that thing doesn't exist. Versus undefined just says we haven't assigned it a value. Okay. In general, you want to treat null and undefined as the same thing, but recognize that those are actually two different values. So null does not equal undefined. And in fact, null, the data type of null is object, whereas the data type of undefined is undefined. It's its own special data type. Empty strings start and end with a quote and quote. There's just no characters in between there, so that we refer to as an empty string. We're generally going to treat that as an invalid value, but recognize that there's an object there. There is a string here. It just doesn't have any characters in it. Similarly, you can have empty arrays. An empty array is an array that doesn't contain elements, right? So all of these things are not equivalent, but they're often common error cases where we want to say, well, this is a special case. So if I have an empty array, this is an array that doesn't contain any elements. Okay. Similarly, I might have an empty object. So this is an object that doesn't contain any properties, right? So empty string, no characters. Empty array, no elements. Empty object, no properties. So oftentimes we're going to treat these values in special ways, and we need to make sure that we pay attention in our code to deal with these cases. So next, let's talk about template strings. Template strings are a really nice new feature added in ES6, and they allow us to create output and HTML in a really slick, readable way. So let's go through what that looks like. So before we talk about template strings, we actually need to talk about concatenation and addition. So in general, in JavaScript, if I put the plus operator can actually mean one of two things. It can either mean addition, to add two numbers together, or it can mean concatenation, to take two strings and put them after each other. So for instance, if I have red and cat, and I try to concatenate those, I'll get red cat, right? So for instance here, let's look at some of these examples. If I want to get addition, well, I'll get addition if I add two numbers together. So if I say 3 plus 4, then I'll get 7. Okay, that makes sense. But if one of these values is a string, if at least one of them is a string, then I'll get concatenation. So here I'm saying test plus 3. Well, here I'm going to get test 3. Right, so this is addition. This case is concatenation, and those are, you can see, two different operators there. Now, it's worth really paying attention to that. And a lot of bugs can creep into your code if you're not paying attention to the fact that concatenation and addition are different. They behave different, and which one you get depends on what type your operands are. So for instance, if I say take the string 12 and then add 34, well, this is a string, right? So this is a string plus number gives me concatenation. So here I'll get 1, 2, 3, 4 as a string. Similarly, if I have number plus string, okay, well, concatenation, so 1, 2, 3, 4. If I add two strings, I'll get 1, 2, 3, 4. So if any of these values are a string, then I'll get a string, and we'll have concatenation. The only case where I get a number with the plus is if they're both numbers. So here if I say the number 12 plus the number 34, I'm going to get the number 46 instead of that string 1, 2, 3, 4. So you want to make sure as you're working through your, especially if you're doing calculations, you have to be very careful to make sure you take the inputs and parse them and turn them into numbers. So you can do that with either parse float or parse int to get it from a number to an integer. Now, that's kind of how addition and concatenation works. Let's say now I want to use that and I want to output some data. So I'm going to say, hi, my name is, okay, well, let's add in their name. And then, and my name is, add in the age and a dot. So I'm using this to log out a message that has your name and your age in it. And this is one way to do it with string concatenation. You can do things this way. I would generally recommend this is a case where a template string works really well. So when you're concatenating together things that you want to be output, whether it be as HTML or to log or such, if you're trying to turn it into a string, template strings may actually be a better fit for you. So rather than writing it out this way, we can use a template string. So template strings start with these little tildes, start with a tilde, end with a tilde. Remember, strings can normally start with either single quotes or double quotes, but if you start and end it with a tilde, then it is a template string. Okay. Now with this template string, I can add in these placeholder values. So here I'm saying $, open parenthesis, close parenthesis. Between there, I can put any sort of JavaScript expression. So in this case, I'm putting the name variable. I'm saying inject the name here and inject the age here. So template strings give me kind of a way to put placeholders in there. So I might do that with a string. I could also do that with if I'm trying to generate some HTML. So for instance, I might start the backtick here, the tilde, backtick. Sorry, not tilde. Backtick, beginning and end. And here I've got, well, I'm going to put the title variable in this h2, and I'm going to put the summary variable in that paragraph tag. So in general, if you're outputting stuff to, if you're thinking about putting stuff out with using string concatenation, I would strongly encourage you to think about, well, maybe this is something you can use a template string for. Because this will result in code that's much more readable. I would argue this, and most people will agree, this is a lot more readable than that with the pluses in there. Okay. Also, when you're writing output, it's frequently that you're going to need to write out numbers rounded to a particular decimal point. So for instance, in this case, I'm saying let's write out inches. Inches is blank centimeters. Well, in both of these cases, I want to round the number that I'm outputting to 2 decimal places. So if I'm starting with a number has a method called toFixed, and toFixed takes an argument that says how many decimal places do you want. So for instance, here I'm saying I want to round inches to 2 decimal places. So it's going to give me inches to 2 decimal places and centimeters to 2 decimal places. Note that when you call toFixed, that it does change the value from a number to a string. So remember, toFixed can only be called on numbers. toFixed doesn't exist on strings. So you will get an error if you try to call toFixed on something that's actually a string. You haven't remembered to parse it yet. Fair forewarning, this is not the method you want to use to round numbers if you're just trying to use it in a calculation. So if in the middle of a calculation I need to round to the hundredths or the tenths decimal place, whichever, or whatever decimal place, if I need to do that in the middle of calculation, use math round instead, because that will give you back a number instead of giving you back a string. So toFixed is for when you're giving the value back to the user, not when you want to do further calculations with it. Do note that, though, even if you round it using math round, it gives you a number rounded to wherever decimal places you want it to be. It will, however, because there's error when you're working with floating point, if you round it and then just output it without calling toFixed, you're likely going to find that in some cases it ends up outputting with 8 decimal places instead of the number that you wanted, because again, there's rounding error. So anytime you want to output a value as a string, always use toFixed. Okay. Next up, let's talk about branching and looping, and generally we talk about these as control structures because we're controlling the flow of our code. So first up would be the if statement. If statement works exactly the same way as it does in C#. You say, here's a condition. If that condition is met, then run the code inside the curly braces. Otherwise, skip past it. So here I'm saying if x is divisible by 2, so x mod a modulus 2, so if the remainder is 0, then we're going to write out that x is even. Okay. Oftentimes when I have if statements, you're probably also going to want an else case. So do this, and if that's not true, then go do this other thing. So in this case, I'm saying, well, is the remainder, is it even? Well, let's write out x is even. If it's odd, we're going to write out x is odd. Now, I do notice that I have an error on this slide because that should be x. So if x is even or x is odd, we'll write out the corresponding message. Next up, you can also use else if, same way it works in C#, where you say basically nesting. This is a shorthand for nesting. You're saying, well, if this is true, then do this. Otherwise, we'll check if this condition is true and then do this, or check if this condition is true and then do this, and then else here. So in the structure, if, etc., down to else, only one of these pathways will run, which is great. So for instance, here we're saying first, let's check if it's not a number. Well, if it's not a number, then we're going to write out x is not a number. If it is 0, then I'll write out x is 0. And then otherwise, if it's not either of those, if it actually is a number and it's not 0, then we'll go determine is it even or odd. So if it's even, write out x is even. Otherwise, write out it's odd. So if I give it a number, it'll do one of those 4 things. And it's worth noting, it's important that I've written this as else if. If I'd written this as just if, then more than one of these things could happen. Okay. Another way that you can write conditional statements, conditional logic, is use the ternary expression. So remember, a ternary expression starts with a Boolean expression, and then you have a question mark, and then you have a value, one expression, and then another value, both of these separated by a colon. So the way this works is If you're happy, if happy is true, well, then you'll get this smiley face. Otherwise, if happy is false, well, then you get this other sort of neutral face. And this can really help, using ternaries can really help simplify some if statements, especially if statements that really only have one line of code in them. Oftentimes you can simplify them down to a ternary like this. It also makes it possible oftentimes to make a variable constant that otherwise would have to be declared with let. Because I can say here, if I wrote this as an if statement, I would have to say let happy mood, and then if set happy mood to this, otherwise set happy mood to that, to something else. So this actually lets me use the const keyword in a place that I might not be able to use it if I had declared this, if I had used an if-else statement. It's also worth noting that you can actually nest ternary statements. So if you have more than one condition, so in this example, I'm figuring out the full mood, which is both looking at the happy variable and the sad variable, not just happy. So if you're happy, you say, well, let's give you the happy face. And then if you weren't happy, well, then let's check if you're sad. If you're sad, you get the sad face. Otherwise, if neither of those are true, this is effectively our else, you get this neutral face. So you can use that technique to have a series of if statements, and specifically this allows you to do something very similar. A lot of times you can take an if, else if, else if, else if, else structure, like we saw in the previous example, and turn it into something like this. So this technique turns out to be very, very helpful. These ternaries turn out to be very helpful when you're writing code in a functional style, which I would really recommend getting in that habit of writing your code in a functional style with JavaScript. Because you'll end up writing code that is a whole lot simpler and a whole lot easier to read and debug too. So we talked about if-else. Let's talk about for. So for loops there's a few different ways to write for loops in JavaScript nowadays. The first way is a simple counted loop, as we might say, a definite loop. So here I've got an example where I'm counting from 0 to 99. So I start out with a variable. I'm going to say let I be 0, and then loop as long as I is less than 100. So as long as I is less than 100, I'll keep going through this loop statement. And then after each iteration, we're going to increment I. So the first iteration through here, we'll just say, okay, well, I is 0. That is less than 100. We'll go through and we'll write out 0. Then we'll keep doing this process till eventually the last one that you write out is 99. Because when I get to I is 100, this will fail. That line of code won't run. Similarly, if I want to start counting from 1 and go up to 100, I would write it this way. I would say, let's start at I is equal to 1, and then go I is less than or equal to 100, and I++. So we keep stepping until eventually we get to 100. This will then log out the numbers 1 to 100. And this should be very familiar to you if you remember any of your C# coding or any of your previous JavaScript. That's how you're going to write a definite loop. All right. So let's say I have an array, right? So a common thing to do with loops like this is I might want to loop over all of the elements in an array. So one way I can do this, let's look at a code example here. I can say, okay, let's create an array named pets, and I'll put a few different values in it. So it has cat and dog and bird in it, and then I'm going to loop through it. So I'm going to start I at 0. I'm going to go as long as I is less than the length, because remember our array indexes always start with 0. So we go up to 1 less than the length. So this has 3 elements, so this would be index 0, 1, and 2. Notice that there's no index 3, which is why we need to do less than the length. Okay, and then we go I+. plus plus or plus plus I. So for each iteration in the loop, I'm going to write out I, and then write out the value of that pet. So this is going to write out as 0 colon cat, 0 colon dog, 0 colon bird. Another way that I can write a loop over an array is to use the for in structure. Okay, so the for in structure looks like this. It still starts with the for keyword here, but what you put in the parentheses changes. So the first thing I put in the parentheses is a variable declaration. So I'm going to say const I. So here I is going to be that index or that key into the array. So I, as we loop through this, is going to be 0, 1, and 2. And then I need to say in whatever array I want to loop it through. So here I'm going to say const I in pets. So I is going to go from 0, 1 to 2. And then each time I go through that loop, I'm doing the exact same thing. I'm saying console log I pets. So again, this is going to run out as 0 colon cat, 0, 1 colon dog, 2 colon bird. So this has the same effect as writing that code here, right? The upside is, first of all, you can see that it's simpler, but you'll also notice in this version that I had to make this I had to make it variable. I had to declare it with let. With for in loop, I can actually declare this variable as const, which that might seem weird, and especially if you're thinking of const as being a constant, this doesn't necessarily make a lot of sense because obviously I is changing. But what const means is that the value of that variable can't change after it's been assigned a value. And the way that this works out is that I, remember const is block scoped, this actually that I goes out of scope after every iteration. It's like I declared the I inside the loop. So the I is a different variable every time I go through this. Similarly, I can do this a little more often than another way I can write loops over in arrays is to use the for of structure. So as you saw with the for in, that gives me the key for each element. For of actually gives me the value. So if I say for of, here I say const item, that's the name of my variable, I'm looping over pets, rather than giving me the indexes 0, 1, 2, it'll actually give me the values there. So I'll get cat, dog, and bird instead of 0, 1, and 2, which this is usually how we end up writing most of our loops. Most of our loops will write as for of, because most loops will be going over arrays, and usually we care about the value but not the actual index. So here I'm just writing out the values. This will come out console log item, so I'll just get cat, dog, bird, each on a separate line. So there's all those three different ways to write loops. So in general, I would say that the for of is the one you want to use for most of your loops. It's generally going to be the right choice. If you do need the index or the key, then I would use for in instead. So if you don't need the key, then use for of, which is the common case. If you do need the key, then use for in. Or lo and behold, if you do for whatever reason need to use parallel arrays, because you then need that same index for more than one array, that would be a good place to use the regular for structure if you have parallel arrays instead of using either the other two. Okay. Another thing to note with the for loop, you actually can use the for in structure with objects. But in that case, what I get is not array indexes, but the names of properties. So here I've got an object with three properties. First is John, last is Doe, age is 30. So here I've wrote a for in loop. I've said for const key, so I've declared this variable key that's going to go over person. Okay, well that key is going to be first, last, age. So the first time I go through this loop, I'm going to have a key of first. I can write that out as first and then go access that property using the object actually as an array to refer to that property. So I can say, so this will come out as first, John. Next time through, I'll get the key last. So this will be last, Doe, and then age comes here, and we'll get the value. So this will be age, 30. So I can actually, if I do need to do a loop over all the properties in an object, you can actually use the for in structure for that as well. It's relatively rare that you'll want to do a loop over an object. It does sometimes happen. Most of the time we'll be doing loop over array, but just so you know, that's why that exists. That's where that is. Okay. And that typically means when you're looping over objects, you're going to use for in. If you're looping over arrays, it's usually going to be for of. Okay. Truthy and falsy. So there's some interesting kind of behavior with JavaScript that oftentimes implicitly values get converted from one thing to another. So for instance, when we talked about concatenation, remember if I add a string and a number, well, I get a string, right? Well, that works because both things get converted to strings, and then the addition happens. Or if I say, let's multiply two strings, I multiply the string 12 and the string 34, well, that can't be done with strings, so they'll both get converted to numbers, and then the operation will happen with them both being numbers. So one of the things that can happen with those type conversions, your values can also be automatically converted to booleans, and that's what we're talking about here. You know, what happens? How does that work to the values implicitly get converted from whatever type they are to booleans, which they commonly occurs when we use them in if statements. Okay. So in general, when we're talking about just some definitions, in JavaScript, when we're talking about a truthy value, we're talking about a value that is considered true when it's converted to a Boolean, when it's treated as a Boolean in the code. Versus a falsy value is a value that's treated as false in that Boolean context. So a truthy value is a value that behaves like true effectively or is treated like true, and a falsy value is a value that's treated like false. Okay. So what values are falsy and what values are truthy? So in JavaScript, we define a few different values as being falsy. First up is false. That one's fairly self-explanatory. 0 is also treated as falsy. But notice that -0 is also treated as falsy. Kind of the same token as 0. 0 general is also, oftentimes we'll think of like false as 0. So these values are all falsy, treated as false. Nan, not a number, is actually treated as false as well. And then null and undefined are also treated as falsy. Okay, so these values plus empty string. So if your variable is any of those 7 special things, then it will be treated as a false. If it's anything else other than those 7 things, your value will be treated as truthy. It will be treated as equivalent to truth. So notable exceptions in those cases, notice that empty arrays and empty objects are not in that list. They're not considered falsy. If you have an empty array or an empty object, those are still truthy, which can mean that you have to have some special cases to deal with in your JavaScript code. Okay. Now, we can use this, we can use the fact that there's this idea of truthiness and falsiness, truthy and falsy, to really clean up a lot of our validation checks. So if I was going to write out everything explicitly, and I want to say, well, is your age valid? I might have to write out quite a bit of code. I might have to say, well, okay, we need to check all of these special cases. So let's check them one by one. So let's make sure your age is an empty string. Let's make sure your age isn't null. Oh, and your age also can't be undefined. And it can't be not a number. And it has to be greater than 0. So all of these things have to be true, and if that's the case, then your age is valid. Otherwise, if any of those things are not true, then your age is invalid. This is a lot of code, and to properly check numbers or values in general, frequently you end up finding yourself writing this much code. So I don't want to do that. I want to make sure all these cases are covered. But I don't want to write out that much code because it becomes really hard to maintain and very easy to make an accident in there. Because notice that I also have how many exclamation marks? 1, 2, 3, and 4. I've got 4 exclamation marks in there that I have to remember to include. If I miss any of these, then the whole thing breaks. So an easy way to simplify this, now knowing about this idea of truthy and falsy, I can actually just write it this way. I can say if they have an age, not comparing it with anything, just treating it as if age was a Boolean variable. If they have an age and their age is greater than 0, well, then it's valid. Right, so I still have to check this side of it because the age doesn't, truthy and falsy doesn't refer to negative values. Okay, so I still need to check that the age isn't negative, but I don't have to check that it's each of these things one by one. So this can really, really, really clean up your validation checks, your client side and server side validation checks if you use this. Okay. Similarly, if I'm working with arrays, I might say, well, I've got an array of pets. I want to make sure that that array of pets contains at least one pet. So I'm going to say, well, is the array null? All right, it's not null, and it's not undefined, and it has a length that's greater than 0. If all of these things are true, then you have pets. Otherwise, you don't have pets. That's a lot of cases to check for, so I can simplify that as pets, and pets length is greater than 0. So if I say, hey, you have a pets array, and that pets array has at least one thing, then you have pets. Note that I do need this second clause because empty array is still treated as truthy, right? These values, null and undefined, are both treated as falsy, so I can take care of that with this, but I still have to check that there's at least one element in the array. Using this truthy or falsy, you can actually use this with both the logical or the logical and operator, and it has some interesting behavior. The most useful one is the way that the or operator works in general. So with the or operator, you can see if I say x is equal to 4 or 3, what I'll get is the first truthy value. So the first truthy value here is 4. Okay? Or if I say null or 3, well, null is falsy, so I'll get 3. Or if I say 4 or null, again, 4 is truthy, that's the first truthy value, I'll get 4. So I can use this. This can be really, really handy because it takes the first truthy value. It can be really helpful for defining defaults. So for instance, if I want to say, let the user pick a port, but if they don't pick a port, then default to 3000, I can write it like so. Take the input port, the port that they selected, or 3000. If they don't pick a port, it's 3000. Or if I want to have them enter a host name, So, well, I say input host or localhost. So this value here is effectively the default value. It's what I fall back to if the first value is falsy. So that can be really, really helpful for having defaults for both your functions and all sorts of places or settings or all sorts of things in your code. Okay, so that's the end of this lecture here. There's another part to this JavaScript, and we'll go over that tomorrow. We talked about a few different techniques for loading JavaScript files efficiently. Specifically, we're talking about script files. And remember, we talked about the whether you put it in the head option. You can put it in the head. You can put it in at the end of the body. The upsides and the downsides there. In general, if that's the only two options you're considering, putting it at the end of the body is the better of the two. But there's also, with newer browsers, have the async keyword that you can use, the defer keyword you can use, or you can use that link preload to tell it to load the file ahead of time. And generally, I would recommend using that defer keyword is usually what you want, and then just leave it up in the head. But sometimes, especially if you need, if you do have embedded JavaScript, then you're going to go ahead and use that preload and stick that in the head. And remember, the preload can be used for all sorts of things, not just JavaScript. We talked about some of the differences between const, let, and var, and we talked about how to declare variables with both const and let. Specifically, I would say, again, recommendation is don't use var for any variables, because there's never a good case to do that anymore. And generally, you want to declare your variables const. As much as you can, declare your variables const. It'll end up making for a better program. And then only use let when you have to, when there's not another option. Data types in JavaScript include string, number, boolean, array, and object, and undefined. Those are your basic data types in JavaScript. We talked about how to implement branching with if-else and else-if, and we also briefly talked about ternaries. We talked about how to implement loops with the for structure, your counted loops, your for of, or your for in. And remember that generally, if you're looping over an array, I would recommend using the for of structure, because it's generally going to be the cleanest. And then we finally talked about falsy and truthy and how to use that to improve some of our branching logic. Okay. That is it for this lecture. There are some additional links and reading material at the end here to find out more about some of the concepts that we talked about. But besides that, I will see you later. All right.